All right. Let's just review a little bit what we talked about before. We are collecting a sample from a binomial distribution, and the sample proportion, the information we get from the sample, is known as p hat. That's a letter P with a caret mark over the top. Another important information we need from the sample is just its complement, p hat's complement. In other words, 1 minus p hat, and we call that q hat. And if p hat is the probability of success for the sample, then q hat is the probability of failure for the sample. In our example, it's what's the probability somebody's not going to go to the theater, or what's the proportion of people that are not going to go see a movie at a theater. And of course, you should all be familiar that n represents the sample size. Okay, our standard deviation for a distribution of sample proportions can be expressed as p hat multiplied times its complement, q hat, divided by the sample size, and then we're going to take the square root of all that. This represents our standard deviation. So, in the previous video, we talked about we have to choose a particular confidence level that we want to be at. How confident do we want our answer to be? And then we have to go out this many standard deviations from either side of our sample value, our p hat value, to determine where we think the actual proportion is. So, we are going to start with 50%, and we're going to go out so many standard deviations this way, so many standard deviations this way, and we're going to claim that the actual proportion of all adults that are going to go see a movie in the next 10 days is going to be something inside this interval. And this interval is known as a confidence interval. How far out do we go in either direction? Well, it depends on how confident we want to be. Let's say for this particular problem, we want to be 95% confident. Well, if we want to be 95% confident, then we must create an interval that goes out 1.96 standard deviations in either direction from this value I got from my sample. So in other words, we're going to take this standard deviation formula and multiply it times 1.96. Okay, so let's actually plug the numbers in. So that's going to be 1.96 times the square root of p hat is, at 50%, that's 0.5 as a decimal, and their q hat is complement, must also in this case be also 0.5. I have to add up to 1. My sample size was only 10, and is 10. Getting my calculator, again, you probably won't be able to see this on the calculator, but I'll show you anyway here. So that's 1.96 times the square root sign of 0.5 times 0.5 divided by 10, close the parentheses, equals, that comes out to be 0.3099. Now, you say, what the heck does this represent? Well, this is a decimal, but remember, in my original distribution here, it can be represented either by numbers or as percents. So I'm going to go out so many percent in either direction of 50% to form my interval. Well, how far am I going to go? Well, to me, to the nearest percent, this looks like about 31%. Okay? So, I'm going to go 31% above 50%, and I'm going to go 31% below 50% to form my interval. So this is going to give me a value of 81%, And this will, 50 minus 31, I believe, is about 19%. Okay. So finally, we can make our final statement. Our final statement then, and this is the type of statement we'll make, and then we'll talk about what it really means. We are, and we use 95% confident level, we are 95% confident that between 19% and 81% of all adults will see a movie in the next 10 days. That is our statement. Now, hopefully there's something really bothering you about this statement. And that is between 19 and 81%. Well, shoot, I could have predicted that without doing all this math at all. That looks pretty worthless. Between 19% and 81%? Couldn't anybody have told you that? Who needs all this math to figure that out? What is the problem here? Well, the problem is we can't be very, very exact. We can't narrow this down any more than that. And what's causing that is that we're using a sample size of only 10 people. When we're dealing with proportions, if I have a sample size of only 10, I really don't know anything for sure. So the best I can do is say, yeah, it's something between 19% and 81%. So let's make a slight change and see how that improves our situation. Let's go, instead of saying I've got a sample size of 10, let's say I've got a sample size of 100. What if I go out and ask 100 people, are you planning to watch a movie at a theater sometime in the next 10 days? And I would get numbers from 0 to 100 then, but the shape would still be similar. But my formula up here is going to change in that I'm going to be dividing by 100, not by 10. So let's do that on the calculator. Let's write that down again. I'm going to form my interval as being 1.96 times the square root of 0.5, that's p hat, times 0.5, that's q hat, divided by 100. Don't forget to take the square root of that. So let's do this again. So this is 1.96 times the square root of 0.5 times 0.5 divided by 100, close parentheses, that equals 0.098. And as a decimal, that's 0.098. As a percent, rounding to the nearest percent, that's 9.8%, or approximately 10%. So now we're saying, starting with the value I got, let's assume that we went out and interviewed 100 people, and it still came out 50%, exactly 50 out of the 100, let's say, said they were going to go see a movie. So now we can say, going out 10% in this direction and 10% in this direction, I can now say with 95% confidence, because we use 1.96, we're 95% confident that the proportion of people that are going to go see a movie in the next 10 days is something between 40% and 60%. Let's go one step further, but we'll do that on the next video.